it's like the current sort of slang. So when they say "don't be a Tesla," or "that person's a real Tesla," they are not referring to the person being charged.
People know exactly what they mean. Like I don't have a problem with that. People get really uptight about innocuous language a lot of the time, and it's silly. And like there's reasons to be upset about some language, and that's fine.
Yeah.
But also some things are just goofy because people are goofy.
Yeah. And I find in Australians, even relative white Australians will use words that we might consider swear words, and they're considered being swearing, they're being expressive.
Well, that's because there's only America and not America. And the internet exists on America, remember? And so because
there's America and then there's Alberta.
The Texas of Canada.
I have witnessed an interesting exchange in British Columbia where a kind of people who were from Alberta who identified as Albertans were being Albertans, and it was kind of pointed out that they were being,
they were being not the greatest.
Well, they were, and their response was, well, we command our sons, in a reference to the change of the national anthem.
Yes.
All the sun commanders, all the in command, right? And they don't like that change, so.
Well, ain't that a darn shame? Real rough, buddy. Hello, everybody, and welcome back to Debate Hub. We're here to not debate. We're not even here to discuss. We're here to watch volcanoes. We're here to do science. God damn it.
Yes.
I hope everybody's been having a good week so far. It is now Friday, so I hope everybody has a lovely weekend. You may notice it looks a little bit different in here. Yeah, I try to make it look a little bit more fancy because I'm always about improving and making things better. So you guys get better stuff. Actually, it's mostly just for me. I get annoyed at, like, I have to move things around. If I don't move things around, I get, like, stressed out about it. So this is a me thing. This is all me, baby. I've got Landon and Maanyaa here with me, and Shipfish for Two said for the void. Yes, Dapper is not with us as of this Friday right now. I think he's going live later. He has a video drop later today, but he will be joining us on Saturday, a Saturday coming up in the near future. Which Saturday it is, you gotta like and subscribe to make sure you don't miss it to find out, because I don't remember which Saturday it is. I have it on my phone somewhere, but I also don't know where my phone is because I'm falling apart as a person. Landon, how are you today?
Oh, I'm doing fine. I am recovering from having watched one of your previous videos that, folks, just go onto her channel and look at some of her previous videos, and when you see it, you'll know what I mean. I'm not making comments. I'm just pointing out that. So yes, and things have happened. I've been doing pretty well, and I'm getting ready for the expedition to see the annular eclipse. And the word annular doesn't refer to like once a year. It refers to Latin annulus, or ring, where the moon will be a little bit too small to cover the sun, and we'll get this nice thin ring around it, which is, annular eclipses are nice. They're fun when you do the little, like you take your hands and you do a little pinhole projection, you get little circles there. It's very, very cute. It's not a total solar eclipse. Those are just off the chart awesome. But it's something that if it's in your backyard, and it's kind of the Southwest U.S. as opposed to Pacific Northwest. It's worth, if it's in backyard, it's worth going and seeing. But anyway, so I'm preparing for that little expedition of stuff. Oh, another cosmic ray shower. I've been monitoring cosmic ray showers, but that's a different physics story. How are you folks doing? How are things
just
going?
Sliding across the screen. Sorry. That was my fault. I'm trying to fix it a little bit, and I'm just messing it all up.
Chesh is a professional producer, so just let you know.
Working real hard. Send help. Maanyaa,
Me?
How are you folks doing? How?
Yeah, what's going on?
So I finished one of the courses from a diploma. I'm about to finish another, hopefully by end of this year. So my diploma is all on its way to get completed, hopefully by end of next year. So that's great. I got A plus in that course. Let's just say I'm not bragging, but I got A plus. I'm good
I'm
at
not
writing
bragging,
shit,
but
so
I'm bragging.
I'm bragging. Humble brag.
Humble brag.
Yeah. Uh, at the same time, I had one of my wisdom tooth taken out, and my mouth is sore as today. Like,
Oh boy.
because I think so. When they take out a tooth from your mouth, they don't tell you that they are basically going to rattle your whole skull in the process. But because you're on anesthesia, local anesthesia at that time, you don't feel it. It's the later when the whole the soreness, your whole skull feels sore. Sorry, when it goes away, and you're like, oh my fucking lord, what
Yeah.
did I do to myself? But I'm much
Yeah,
better
it
today.
is.
So
It's a problem
yeah.
with oral surgery because even if you
Mm,
put on headphones and other things, the sound through your
yeah.
jawbone into your skull, yeah,
Vibrates.
it's
Yeah.
and so
And the further it goes away, from the source, the more the vibrations become like more in longitude of a wavelength. If I'm not wrong, that's what I said.
yes,
Yeah,
and you
just like an
find your
earthquake.
resonance, and so Maanyaa, you found your resonance modes for your skull because those
Yeah,
the particular frequencies that rattled. I'm not saying that you're empty-headed. I'm just saying there's a natural
there's something
cavity
gotta be there
sound.
for it to rattle, right?
Yes. But
Something.
yeah, so my sympathies for that
Thank
procedure.
you.
Speaking of vibrating and exploding, we got volcanoes to talk about today.
Yeah. So
Yeah.
Maanyaa,
By the way,
do you do you have the previous predictions from last month?
of course I do.
We did
So-
do, for anybody interested, we did do a mini catch up during the tavern because there was an eruption that happened. So if you wanted to see that, it is both in the tavern and there is a video that is that section of the live stream. So if you'd rather just watch the One Piece, you can go spend 1,000 episodes finding the One Piece, which was just the friends we made along the way.
Yep.
Okay. All right. So Landon said we will continue to see earthquakes moving down southwest rift zone. Don't know how far though. Not see lava on the surface. Kilauea won't erupt. Continue to see weak depression and deflation and inflation events.
Deflation,
Gas
inflation,
levels.
DI.
Yeah. Gas levels will be around the same level, around 75 tons per day.
Okay.
So, and then April had said more outgassing, less lava flow. Are these the ones that? Oh yeah,
Yep,
these are the
this
ones
is
that we
right.
had last time. Yeah.
Yep.
Yeah.
It's been a while, Manu. You got this.
Yeah. It's been a while.
It's because we talked about it on the tavern. It's thrown you for a loop a little bit.
Yes, of course. Yeah, Gup's prediction was quite accurate because he had said it will erupt again on 9/11, 23rd? Yeah, 9/11, sorry, at 5:23 a.m. And I think so he missed it by an hour, 2 hours or something like that. I don't know. But
Very
yeah.
short amount of time.
Yeah. And I had said that Spine will, on the southwest side, will open up and spill out. New island, lava fountains, blah, blah, blah. So, and Shesh had said, going to see more intense earthquakes, higher, richer scales, start to see more gas as lava and magma move around. And then Alicia said, island will stand up as Te Fiti and we will get a monster tick up.
Hell yeah!
Hell yeah.
Alright, so what did we actually end up with?
I think the Gup was
Well, so they're kind of interesting in terms of those predictions, and as I say, the person again, the person's handle name is
Gup.
What?
G-U-P. Gup.
Gup. So Gup was fairly spot on in the prediction about the eruption. And Kilauea did erupt for several days. In terms of my prediction, if you ignored the phrase "no lava on the surface," it turned out to have been fairly accurate. But of course, no lava on the surface ignores the fact that there was lava on the surface.
A lot of lava on the surface.
DI events. So shall we look at and the term, the sort of the vernacular term is called volcano porn.
Yeah.
Just for YouTube censors, don't feel bad. This is all safe for work. Porn is like when you show the public red lava stuff, right?
Oh my god, Bapt for 5. Thank you so much, Bapt. Said, who knows, the gas levels might be less toxic than Jared Genesis.
Oh.
So for anybody who's been watching on Twitch, you know what he's talking about.
That of course that would require you to do measurement on Twitch for things, and I don't know that measurements have been performed yet. So here, yes, so Kilauea volcano erupted, and it was rather spectacular in terms of its brief appearance. She had a very short little jig, a dance, Madam Pele, and she surprised us in terms of where the lava came out. So the lava did not come out on the southwest like it had at that previous side vent, and the earthquakes were suggesting. It went the opposite side of the Halemaumau lava pit. And so here we're looking at the sort of the fissure when it's well developed. So we see in this picture, I don't know if you can see. Can you see my cursor down here?
Yes.
You see that? Right. So the lava lake area, is the lava lake sort of starts around here, and this zone is going up on the down drop block, right, to the edge. So we're seeing up here is up in this area here is the bottom of the caldera, right? So this is the collapse pit, and this is the block, down drop block, which kind of collapsed a little bit later, and so it's kind of tilted up to the side. You can see this rift went up to, and in fact, you look where the cursor is up here. There's even vents that were suggesting going up the side, heading. And by the way, this direction is towards the visitor center Volcano House. Obviously, Volcano House is on the very top, so you're only seeing right now the inner caldera wall in here. You can gets up barely up to the edge. So it was well within the caldera, but the rift cracked open, and it actually went up to as far as up into this area of the. And so it surprised people. Now, it was interesting as well. We had a camera that was installed. You might remember the previous thing where we talked about, showed you the influence of the camera. That camera was placed right over here. So the camera, it was kind of lucky that the camera didn't get zapped. In fact,
I remember,
all this. Good.
I remember I had commented about the vicinity of the camera to the mouth of the volcano. I'm like, isn't it too close? But it survived.
But if we had been doing these shows 10 years ago or more, would have been on top of the Halemaumau edge, where you had the little drain hole there, a little relatively small lava lake. And there were cameras that would be perched on the edge, and there'd be an earthquake, and the camera would fall in. In fact, we even had a case where a camera was tumbling, taking a video frame. You can see the video frame as the camera was falling into the lava, going scan, stop. Right. So we've had numerous cameras sacrificed to Pele. She has a good taste in cameras, I must say. And so
the Nikon
that's just sort of
P1000, the flat earther camera of choice.
Well, astronomy keeps developing better and better cameras, and some of those camera imagers are given to USGS. Sadly their funding is woefully low, and so some of the cameras then get put in there. So they have some high quality cameras taking data, and as expected, these instruments will get sacrificed on occasion. Because of the lava pit, we've had a period of a number of years where the lava has been relatively contained, and that's somewhat unusual. This having rifts and flows down is more the typical thing that Kilauea has. And you can imagine, putting cameras, like if this was a stable, you try to put cameras up as close to the lava flow as possible, and occasionally you get breakouts and the camera goes away. So you put another one back. Anyway, so this is shows you the rift is opened up. You can see the fountains were quite high. These heights here. This is about 100 meters, about 300 feet plus. I don't know how many washing machines high that is, but it's a bunch. And so it had a fairly, and the gas was quite high. The gas levels here were the first day or two were in the 150,000 tons per day level. Lots of gas. Now, interesting is that when this quake happened, we saw earthquake swarm, but most of the earthquake swarm was to the southwest. This is to the east of there, and it very rapidly went to. So now we had, as we saw in the tavern, we showed you the very beginning of the eruption. It was during the daytime. We see the very beginning of it, and it started in this area here, and it quickly went to this rift, going forward. We also and a lot of
we might
lava
need you
came
to
out.
zoom that one in a little bit if you could, Landon.
Let's go. A lot of lava coming out. You see here the lava front.
Sir, that is a
lava...
Dungeons and Dragons monster traveling underground. Excuse you.
Is it Lothbrok?
Yes. So the actual the
chunky dragon.
The vents and the rift are off to the side here, and so you're seeing the lava rapidly move around. This block that's moving around right here, right? If you talk about in this area here, moving down to this spot, this area here was a high point. Remember, in the previous eruption, the eruption ended with a little vent on the side of the caldera, pouring lava in, and this was its sort of base of its flow. So that kind of acted like an island, moving this stuff around this front. So the front fairly quickly covered the caldera floor in lava. And again, most people think of lava as the red stuff, and understand all of this material back here. Right, all of this is lava, right? Even though you don't see it as red, this is quite hot. But when lava comes in contact with air, cold air, it freezes and develops a rock sheen on the surface. And so when people say, where's the lava? It's not the red stuff down here. All of this is lava.
Yeah, that's all moving, right?
And yeah. Oh yes, moving, and it so quickly filled the floor pretty well. And you could see that as the eruption progressed, it started favoring one spot. This is very common in beginning of Kilauea eruptions, even along the spine, where you'll get some earthquakes, gas, and then all of a sudden you get a fountain, a curtain of lava along a spine, where it's coming out all over the place, and it quickly evolves into one or two spots that kind of get cleaned out where it has the easiest flow. So these other spots where lava is coming out kind of died down, and it ended up favoring a spot, as you can see in here. We looking up in detail of this thing. It begins to favor certain spots and diminish in certain areas. If you had been to the visitor center or overlook, you would have seen this. So here again, now we see the long rift. along here. We see all of this dark stuff here. This is all lava, and you would watch it be slowly oozing like
it's one of those situations
sort of
where it's a lot easier to see it. The nighttime pictures are almost always.
Yes, but again, I want to emphasize. Most of the time, lava looks like rock because lava is rock. Guess what? And it's only when lava is moving rapidly enough that it hasn't had a chance to freeze in contact with the cold air that you get the red stuff. And we were particularly intrigued by this fountain up here. So here again we see the top of the caldera. The bottom of the caldera is right in this section here. So let me get back to this spot. And this section here, so this is the bottom of the caldera. The visitor center and Volcano House are in this area here, and this is this down drop block. So when people talk about filling up the Holy Maanyaa pit, most of the lava lake is off to the side, and so off to the side of this image, this is sort of that drop down block that's kind of sitting to an angle. This is the floor of the classic caldera. So this was the collapsed pit. And we can see that there's a weak fracture heading up this way. Although we also see cracks this way, that magma worked its way up into and started the eruption on the surface. And as I say, it was a pretty spectacular stuff. It kept going for quite a while. As I say, it's you can see here is on the 10th. This was about an hour and a half old. This is Hawaiian time for the time stops here, and so the camera was sitting right about here, and this lava flow went this way, this lava flow went this way, and actually the camera still was intact. It had a very interesting experience. Let's look at some more
Level up.
volcano porn. But again,
it's
eruption
a
events
rainbow
of stuff are not the end of the world cataclysmic doom. It's a natural part of the process, and Hawaii is known for its rainbows. You can see on the license plate it has a rainbow because there's lots of rain and lots of water droplets due to refraction. So rainbows are actually quite common, especially in a particular time of day. Like in this part of the island, as the afternoon cools, sun is beginning to get lower. The ground above the ocean begins to cool. That air contracts. It pulls moist air from the ocean up the mountain. You see in the distance, this is Mauna Loa, the big volcano. It looks like a little bump, but recognize that edge is way far back. This is a 4,300 meter, 30,000 plus foot volcano, and so air gets drawn up into the heights where the temperature drops, the air condenses and rains. So you can almost guarantee that there's going to be on a daily basis around maybe mid-afternoon you'll get a shower for a brief time, and then the sun will come out and you get rainbows. So lots of rainbows. Again, we can see the lava fountain and some of the flows that occurred. The camera, that camera I'm talking about, is sitting right about here where the cursor is, and we can see this is drone footage looking down. We can see remember that fountain that was up on the edge moving this way. So the camera was sitting right about here, or is sitting right around here.
Question from Feli in the chat. They're asking,
Sure.
How high can the lava spouts go for this particular caldera, as in like the physical lava, not the smoke?
It can get, Kilauea's had fountains that reached 700 meters, around 2,100 feet in the air. So it can, particularly if it comes out in a very small hole with lots of pressure, can get quite, can go quite high. But usually, again, it starts spurting very high, and slowly that vent widens. And, and because it's a wider vent, pressure goes down. It also begins to crack, right? You can see all the cracks in this area. And obviously, there's a weak fault leading up this way. So the original eruption that was in this got reduced, not only because that hole got bigger, but also the pressure was cracking along here, and lava was coming out, reducing pressure. And so it didn't get, well, it got somewhat close in height to this down at the bottom of the caldera here when it first started, but that height drops. And so that's again, if it initially, it has to start from somewhere. You start to get a tall fountain. That pressure that's coming out, because again, as the magma moves towards the surface, the pressure drops. When the pressure drops, dissolved gases that are liquid form boil, and the boiling accelerates the loft of the magma. And so as the magma finds a hole, now you have magma that's boiling, and it violently begins to expand and will rip a long chain that will result in lots of flows. But as time goes on, those harder to reach extents of that chain begin to freeze, because the pressure drops. The upward pressure drops it's relieving the pressure. So you can see in this picture here, you see how these vents might be hot, but they're and driven a little bit, but they're mostly finished, and the eruption then sort of concentrates into some small area. So you get the initial spurt, high fountain, then you get the chain or the curtain of fountains, and then it begins to favor one or two spots, and then the eruption continues. So we can see here is the extent of the lava pit. This is the drop down block, elevated spot, and we can see the sort of right on the edge. We had thought that it was going to come out over here, because that's where the previous side vent, that's all the earthquakes that we were seeing in the previous set was heading in this direction off here. This pit used to be quite deep. It's filled up mostly with rock, and so apparently when the magma was reaching toward the surface, it couldn't break through the center of this rock and went around the side. And instead of going in the area where the earthquakes are, it went the opposite direction. Surprised people.
That's so cool. It's so hard to predict. There's so many factors that we just can't process.
It's a chaotic system, so small changes can result down the road into large events. So some, the magma coming up underneath the lava pit, it kind of had a chance to go one side or the other, and some small little bubbles set it off the direction of what we thought it was going to do. And remember, again, we were seeing the quakes in the opposite direction, thinking that the magma is cracking that rock, and that would be the weak point. But we were wrong in terms of there was a weaker point here. Here is again, you're looking at the Maanyaa pit. You can see up here, this region, you can see this is the Volcano Museum, the former now defunct because of earthquakes sliding in there. The visitor overlook is over here. So had you gone to the overlook here or here, you would have had a really nice view inside the Maanyaa pit. And you can see how high it has to go before it gets up and over the walls. Even the old caldera floor, it's got a little ways, fair ways to go in terms of a couple hundred meters. That being said, these eruptions are sitting here in the center and not really bothering anyone. But it probably would be a historical mistake.
Dancing in their room alone.
And it might be a historical mistake to assume that what's going to happen is this lake will get higher and higher and higher and build up and then spill over the edge. That eventually will happen, but more likely magma will open up one of the two rift zones and go to the east or to the southwest. Why? Because that's where most of the bulk of the volcano is. That's where most of the stuff happens. So it's probably not correct to assume it has to fill up the caldera first before spilling out. Prior to 1790,
Right.
this entire caldera wasn't there. It was more of a dome shaped thing, and that collapsed in 1790 and changed the Hawaiian political landscape, and was led to the kingdom of Kamehameha. But that's a different story. Looking here, here's what it would look like if you would have been to the visitor overlook. It's, even though this building is now closed because of earthquake damage, you can walk out into the nice parking lot and walk out and look down here, especially at night. It's quite a nice thing. So it was a very nice view from the visitor overlook. And as I say, a lot of samples were collected in the area. Let's go back to stuff here. I'll go back to here. So yeah, again, here we see a better idea about this is the lava. This is the Holy Mamo pit in this area. This is this crack. You can see there's a weak point. There's a bunch of where the fountains occurred. The lava flowed out and spilled down around here. So it flowed downhill into the pit and helped fill it up. When this area's work, these areas here with lots of cracks are sort of very hazardous. So there's a reason why I put the camera down into this region here. Interesting enough that the lava kind of powered up in front of it, but oh, excuse me. Yeah, the camera is actually right here. But this area here was easy to land until the lava came there. So again, we can see the flows here. Again, we see fresh lava here. Mostly what lava looks like is the silver stuff. And as the eruption continued, these fountains kind of died out, and it started favoring these that are above the lava pit, flowing down into the lava pit. Here again, we see a better, in the bird's eye view. Here are the fountains that start kind of extinguished, and you can see the draining into the lava pit down here. We're able to land people. This is not me, but landed in this area because at this point these vents are extinguished, and we can tell both thermally and visually. So landing here was easy to do to get access to the fresh lava. And you can see here the typical sort of thing the person has. Basically a fire retardant suit to both cooling and safety. They have a gas mask on. They've got communication. There are spotters, people that are carefully watching from the air and from the ground in approaching the stuff. They have 3 different access points to evacuate. There's somebody who has a word where, there's actually, depending on how serious the situation is, they can basically have a thing called drop, which means whatever you're doing, let go now. And they'll might say drop, evac 2. And that means even if it's expensive, drop it on the ground and go back on route 2. Don't wait for explanations. So the whole protocol for approaching it, but that is, you could see, is to come up to this area and sample this lava to understand the composition of the lava is going to tell you about the magma, its movement, where stuff is boiling. Even though a lot of gas comes out here, there still is lots of bubbles in this fresh lava, and that is very useful from an analysis point of view. So things are approached, samples are taken, and you get out of there. You can see on the ground, this area before those fountains are shooting up all that stuff, the wind carries. And so these are sort of the droplets of lava bits there, fresh stuff. The material is brought in. the surface stuff is a lot of glass. I mean, usually the very top of the lava has lots of silicates, lots of glass. This is essentially silicates.
Is that what makes it look silver?
Yes. Also the minerals will give it silver stuff. Over time, that thing will oxidize, right? The chemistry of the atmosphere and the lava react, and it loses its silver tarnish for there. But it's a fairly, this is what the top of the surface looks like. And these rocks were brought in for analysis. These were not samples taken. These were blobs that were thrown out from the vent. So when you're talking about
blobs
here,
thrown out from the vent, okay,
lava bombs, right? So these blocks
damn.
Here, when you're seeing stuff that was back there with the big sprays, right, where it was spraying over, they stuff was carried out by the wind, and you get a rain of these sort of hot molten rocks that land on the ground. So some of this stuff, but also some of it is going into the actual lava, grabbing a sample for analysis. And these are showing the analysis, showing the size of the bubble. But inside here is trapped gases that will be pulverized and analyzed to understand what's happening. This is one of the lava bombs thrown out. You can see from centimeters, it's a fairly big blob. This was a molten blob that came down. It sort of semi-solidified in air and came down with a splash. Here again, we see, so September 10th at we can see the evolution of the flow as you go down.
Landon, we might need that one zoomed in a little bit, please.
Okay, let's go in here. Thank you. So let's look at stuff from here to here. We can see the beginning of stuff, the flow advancing more down here. You can see that you still have the full curtain.
That lava's coming to slide into your DMs. It's just drifting. It's the deja vu.
So this area, this slightly raised area where it's coming around, the previous eruption, this side vent was right over here where my cursor is sitting, in the far bottom right corner, and so it flowed out of that side vent and kind of built this raised up area, which is why this lava is going around in an arc. It's basically going around the raised spot. Now this is a raised spot, and that stuff is lower, but that's a different matter. If we look at another set here, from the thermal images, we can see here the perched basically the pond that here's a big lava lake, and here is the rift with this lava pond that's draining into the base. So the previous eruption was on the side over here that flowed into this area. The reason why this is cold is because it's slightly higher. When it was pouring from the side and partially filling this area, this lava obviously went around. So that was that flows we saw was of lava going this way. But we can see that it had spots up on the side that drained in two ways. And luckily the camera that was on the thing was sitting right there in that cold spot. It was like a lot. People would
roll the dice and got a natural 20.
Yes, and people would say, well, that camera is now blessed by Pele, and it's considered to be an honored camera.
Pele's like, you can stay. This is fine. I like this angle of me. Thank you.
How about trying to auction it off and donating the
it's still
to Hawaii Fires or something like that?
It is still in use. We can still see from that area, and it really had a nice viewpoint. Actually, this spot here, this cold spot, is also a little bit higher. I think the part of the placement was we wanted to place it near the Holy Mill crater of Lava Lake, but on a higher spot to give it more time to survive. Because eventually that thing will be covered. But there's another high spot over here but that probably would have been gone. So it's just a matter
Brian
of
Stevens was kind enough to give us our obligatory "do not swim in lava."
Yeah, warning. Yes, yes,
yes, yes. So we can see from here how the flows advanced from the 11th here, right? So if we look at this spot here, here's the 11th, and you can see the one spot up on the side of the drop down block, and the main flows this way into the lava lake behind here. But if we then look over here, how it evolved, that flow kind of stopped, and the main area was the lower vents that evolved from a thermal point of view. So zooming back here again, you can see side by side comparison of how it changed. This part of the fountain stopped and began to cool off, and you can see here is this dark area. It was the pore. Remember, the southwest rift zone is this way, and that's where the vent occurred. That poured in here, so this is a little bit higher, so the lava kind of went around it. But that's the way that the lava flows. So we had some really nice.
That's a shirt tagline. That's the way the lava flows.
It's one of those things where couldn't it go over there and be more photographically interesting? It's like, no, that's the way the lava flows. First off. So the people that landed down there on that higher block were able to look into these fountains. And so you see these large blobs. I mean, when you saw the pictures of those rock lava bombs, I mean, lava bomb is really just a blob of molten rock that cools in the air and kind of semi-solidifies and goes flat.
Why am I like this? That's what it looks like when I sneeze on my period.
Oh God! Ah, yes. We needed a period joke. Yes.
Too much information.
Nobody should let me.
Nah, Landon. That's not too much information. That's not too much information. That's a universal fact.
This is I had a bloody nose, and it was starting to get better, and then I had to sneeze, and I was really worried about it, and this is what came up.
Yes.
Or someone told me a joke while I had tea in my mouth, like she's saying, "Oh, because they're humans, and me just spitting it out all onto the screen and onto my keyboard."
Yeah, you feel a little bit dry,
and I've done that. She's done that,
and then the sneeze comes, and it's like kabam, right? Yes, but these blobs here, I mean, these are car to truck size chunks of rock that are being thrown up high in the air and come down with a splat. A public safety announcement: do not be under lava bombs as they fall. You will not have a nice day.
Tom was asking in chat if the lava bombs from we talked about a movie a little while ago. I can't remember the name of the movie. Dante's Peak. At Dante's Peak, the beginning of the movie, or the when the eruption is going on, there's lava bombs, and they were asking if those lava bombs are accurate. And from the description you're giving, it seems like that's the case.
Yeah,
or relatively.
And you can see. So here's a lower fountain, a little bit lower fountain, and these blobs essentially start plopping and piling up cones. So this bulge around here came from all these
not quite liquid,
blobs,
not quite solid,
slamming down and congealing.
Well, it's like, it can be really dangerous to be around that area where such splatter is happening.
Yes, and the wind is one of the things they take account of. Not only do you not want to be breathing this gas, even when you have a gas mask, you don't want to have to rely on the gas mask all the time. They have gas sensors there, and if the gas sensors get to an alarm stage, you leave. If the wind becomes variable, you leave. They're monitoring the wind patterns away from the area, so the wind begins to shift. you leave. These are all various reasons to not be in this area.
Many reasons.
And here you can
not.
see fresh lava. The heat is causing this thing to come out of focus because it's hot. And so in this area here, you can still see gas at this stage. We're talking about the times. This is on like the 14th. Was it the 14th? Actually, this is I think this particular one was on the 14th. Yeah, that's right. This is on the 14th, and you can see that instead of 150,000 tons a day, it's down to about 40,000 tons, but still lots of gas coming out. And there's also those lava bombs. It's building up these mounds.
Little hedgehog holes for little demon fire hedgehogs.
Oh,
there's
yes.
still a lot of lava coming out.
Quail Pokemon.
It's just some of these are now being hidden inside the mounds. The holes have opened up, so it doesn't have quite the oomph to reach high, but the volume is still quite high. It's still pouring out at a prodigious rate. It just has opened up the hole and it's not as fountainy. And again, looking down on it, we can see where the former. Let's go back to the original here. Where the former place, the older vents, it kind of stopped, and it began to focus on a couple of vents in this area. Still at the edge, just above the edge of the lava lake, pouring into the lava lake. Moving forward. And again, here's another thing about those primary vents. So by the 14th, it began to favor these fountains. And the fountains were, and if you watched, they kind of ebb and flow. So the period was about 20 minutes or so, where you get high fountains and low. What's happening there? Well, fresh magma moves towards the surface. The dissolved gases boil. You get a big push, and it comes out on a foam for a couple of minutes. That material begins to sink back down into the hole and impedes other magma trying to come to the surface. The fountains kind of die down a little bit. Don't stop, but they go down a little bit, and then there's a turnover. The new fresh magma works for the surface and goes foam again. So these go through a cycle of high and low splatters. Here we can see a little bit lower stuff, but again, now you can see the lava bombs build up these little mountains around the side. It can evolve. I like this particular picture here. Here's a case of now this is the period where the lava on top and the magma that's outgassed is impeding the magma below and sort of drops, and so the fountain almost gets extinguished. But in a couple of minutes, the magma below will invert. New magma will come to the surface and go boom again. So these cycles can build. So you can see this area had a lot of high fountain stuff. This edges around here came from those lava bombs building up a nice cone. Here's another picture. You can see the flow heading down into the caldera.
You can see the waves of it. Yeah.
This looks
and
like
it's fun.
The
These little crinkly stuff. Good.
These look like the burrows for Rek'Sai from League of Legends. That champ.
Lava Rek'Sai. The giant.
Yeah, why not?
The giant,
right?
Pseudo scorpion sand shark thing.
Yeah, void. Yeah, from the void. Yeah.
So here, as it moved on, and here's one of the low cycles where that particular caldera we saw had barely a trickle, and now it's getting up higher. So it kind of comes and goes. It also pressure-wise, if another event starts bleeding off pressure, then it will drop. So it kind of varies in terms of spots. Here's another thing of that same.
There's a lot of gas
side
going
vent
on as well. Yeah.
Yeah, a lot of gas coming on. We can see up here. Here is the picture of that side vent that was up on the side of the. So this top here is the bottom of the caldera. This is the edge of the drop down drop block, and this is that highest vent that started here. But it was at the extreme edge of the crack. And as the pressure dropped, why? Because the holes or the vents down closer to the lake opened up. It lost its pressure and that vent stopped. So you can see from the set here that the eruption was pretty nice.
Oh wow, that looks
going. Just have a few more of these. We're gonna pour, and I'm going to show you this area here with. Now you can see. So this time we're talking about the 17th, right? Where now that the eruption has pretty well died down, and you can see the mounds of those vents. And the flows from here. So this sort of lighter, this lighter brown is wind-blown rock.
Can't help it. That makes me.
First up, you can see the sets here. First off, and so on the 17th, it's typically still erupting. I mean, there's a little bit of stuff coming out here. The flow is much lower. Some of these vents.
This is in the pit, right?
Altogether. Yeah, so we're still talking about those same men. The Holy Maanyaa pit is off to the side. This was in the down drop block. We'll see on the map. This is that rift going up here. This is not in the lava lake because the lava lake apparently is too much of a barrier for the magma to come up through. At that time.
Too unstable. It's like too Yeah.
So this is showing again the drain down to the lake. We can still see there's lava flow here. So even though you don't see a fountain, there still is material coming out here and flowing down for that. Here again, you can see it pouring from the. So here's the down drop block here, the rift, and it flowing into the lava lake. And
I like that picture.
it would come up and down, right? It would go up and down here. For example, most of them. Lava was coming from this vent, but it was fairly wide, so it didn't have as high of a fountain as this one, but it had more volume coming out of it. So a few more. There we had courtesy of a nice little thing showing you the movie. There isn't really sound here; it's just pretty.
Now this is the type of prawn that you don't have to mute.
Yes. So this is on the September 16th. Come on. Well, I should have preloaded. I apologize.
Madam Pele, don't abandon us, please.
Just thinking about it.
Show us your dance.
Come on. Come on.
We believe.
Get it there. Oh, here it is. Okay. There it is. So you can see it live, the live.
Oh, wow. Oh.
That's cool. I mean, considering like what we've seen and what we've watched, and sort of like the unpredictability of volcanoes and sort of and their effect on the world around them, is it really any surprise that like ancient people would have came up with things like gods and like with that exceeding amount of power?
Yeah, because people
not surprised.
try to get a reason why something happens.
Yeah. It's just
people try and predict
gods
things.
used to just be a prevailing theory. That's the
Yeah. So right now so it started around on the 10th of September. It stopped around the 17th. So it had about a 1 week run. So apart from that, little bot, my prediction was true. Of course, that's like the
I mean, I also technically said there would be more earthquakes and there would be lava moving, so
so yeah.
Everybody was right.
But not as good as the chat person again. And so now the emission rates are around 150 tons per day, right? So back to pre-eruption levels. That's essentially the lava that came out is still kind of outgassing fumes from the set.
So before we move on to look at the measurements for current, now that we've caught up, we should take a quick break because we have been live for an hour. Let everybody refresh their drinks, go to the bathroom, get a snack, etc., etc., etc. And we'll be right back.
Yep. See you in a bit.
Maanyaa is taking 3 years. Where are you, woman? Oh, there she is. Alright, we can start again now. Hello, everybody, and welcome back. Is Landon back?
Hello.
I assumed Landon was back because I saw him typing.
Yes, I'm back.
Hey, alright, huzzah, we're back. Welcome back, everybody. Thank you so much for joining us on this debate hub where we are looking at all kinds of everything. I believe we have caught ourselves up on the eruption that has happened. But we have not caught ourselves up on what is currently, like, the current activity.
Yes.
So much room for activities!
Yes. I want to say that from a historical perspective, Kilauea erupts about half the time. So it's one of those things where you flip a coin as to, at any point in time, is the volcano erupting. But to predict it is difficult. It's sort of like, on that coin flip, heads, Pele wins, tails, you're wrong, kind of a thing.
Heads, I win. That
being said, the even though we kind of laugh at how some of our predictions go wrong, the general trends of activity and the region are correct, right? And
being wrong is the fun part.
The details sometimes can be quite surprising, right? And so we learn from what Pele does about volcanoes, about volcanic processes, and we try to make guesses. And then when you find we're wrong, we then look at the data to get a better idea about what happens. So it's not a case that we don't know what we're talking about in detail. It's just like saying it's hard for you to predict whether it's going to be raining or sunshine a year from now. But given your climate, you can give odds as to the fact that it will rain at some point. Just when and how much in the far future is difficult to understand. The general climate and its change is something which is understood. Specific things about a forecast or not. Same sort of thing. Right now, Kilauea is not erupting, and it would be very surprising if it started erupting right now.
Does volcano count as weather?
Well, it's a chaotic. In some ways, you might say there's a chaotic process of when that magma's working its way up through cracks. You have information that small changes down below can have big effects up top, and so you try to understand general trends for things. And had the eruption cracked its way through the lava lake and came out of the center of the lava lake, we would have said, oh, well, that's a weak spot. But it's where the rock breaks and where the thing goes that is harder to pin down exactly.
I wonder if we should get Maddie side up to swing on by for one of these one time, and
that would
be
talk wonderful.
About how weather affects volcanoes and how volcanoes affect weather.
And on Dapper Dino's program, she had a very, I thought, succinct and correct thing about what is a volcano and how volcanoes work. There was some creationists that got volcanic stuff flat out wrong, and I thought she did a really good job of summarizing the general gist of volcanism. That would be a fun conversation to have with her about. I don't know how much she follows in terms of Kilauea, but she knows a lot.
I'll reach out to her and see if I can get her in the next month or two.
That'd be fun. So on this show, we emphasize a lot about the trend of the volcano. and we look at some of these eruptions, like this 8-day eruption is a very typical thing in Pele's history of these short eruptions followed by medium pauses. That's kind of that's a historically common pattern. The 35.5-year eruption from January 1983 to August 2018 was unusually long period of stuff, but also there have been equally long pauses as well. So what we do with the show as well is we then look at what's happening right now. This is yesterday morning. And make sure this is.
We also have a couple questions from chat if you want to field those first.
Sure.
Or if you want to save those for later.
Sure. How we want it to go.
So Tom Riddle is asking, are shield volcanoes almost always bigger than cone and conical volcanoes? They said that their 9th grade physical science teacher told us that shield volcanoes were always much larger.
So shield volcanoes, I guess we have to ask, what does it mean to be bigger? If you're talking about in terms of volume, shield volcanoes are often bigger, but they start off small, right? That's another thing is that some of the andesitic volcanoes, like for example Mount Baker or Mount Rainier, can be quite tall compared to their base. The volcanic eruptions that are continental tend to be lower in temperature, higher in silicon and sulfur, so the lava that comes out is more pasty, more viscous, so you tend to pile up higher. Whereas shield volcanoes, typically the magma coming up is higher temperature, lower in silicon, lower in sulfur. So higher temperature, the lava flows much more easily, less viscous. So it flows out much easier than piling up high. And so from a shape point of view, andesitic type volcanoes like a Mount Rainier, Mount St. Helens, tend to be higher peaks relative to their base. Things that are more basalt, like you see some of the oceanic volcanoes, tend to have more higher temperature, lower viscosity, more fluid stuff, so the lava flans out wider. So they tend to be wider. But in terms of volume, particularly because the sources are the area of the continental, like the oceanic plates, are thinner, so it's easier for the mantle material to work its way up through holes in the plate. They tend to have higher volume, higher temperature, higher volume, so those tend to be bigger in volume as well. And Mauna Loa is by far the world's largest active volcanic system. There's a debate about there's another subterranean volcano that might have been bigger in mass than Mauna Loa, but there's debate about whether that's one volcano or several. Just like saying the entire Hawaiian chain is not a volcano, it's a series of volcanoes. I still live in the camp that Mauna Loa is still the largest by volume mountain in the world, and that's because it has very high rates. We saw when Mauna Loa erupts, its rates are staggering. Lots of lava, very fast moving, covers lots of area, so it doesn't create a huge peak. It creates a more of a flat shield-like volcano.
Yeah, we also got a follow-up question that says, they followed up to answer and said, the professor had said that the altitude was shorter, but the width and overall size were bigger. They then followed up and asked if a shield volcano can ever experience a lateral blast, or if they can only go up.
Yes, they can have. We talk about lateral as in a quake, or lateral as in.
I think they mean lateral as in like can can the like we've seen Mauna Loa, or we've seen Pele kind of come out different sides and go different directions. Is that possible with a shield volcano, or is a shield volcano more limited in where it can actually erupt from?
And I think they've raised a good point. In shield volcanoes, there oftentimes the lava comes out not at the top but on the side. Shield volcanoes develop these sort of spines, sometimes 2 and 3 spines, where there's rift zones, and the magma, instead of always coming out the top and going down, will come up one of those side rifts where there's a fault, a crack that gets developed, and so you get the fountains and stuff coming off of there. So we had in Pele's history, the 35 and a half year eruption was almost entirely along East Rift Zone. There was little small bits when the Halemaumau Lake was a tiny, small, like 100-meter wide lake, and it had a little bit of dribbles over the edge. But apart from that, the 4.5 cubic kilometers of lava that came out along the East Rift Zone. That's a very common thing. So the mountain it isn't the case that the lava comes out the top and goes down. Oftentimes it goes along the spine. It grows. Also remember that volcanoes mostly grow from inside. A lot of the growth of the mass of the volcano is not from stuff coming to the top and the surface, but pushing inside the volcano and expanding it from the inside. So it has all these cracks where the magma is forcing its way up into, causing the mountain to expand. And we see this from the tilt meters and from expansion stuff where the mountain begins to expand, continues to expand, but it's not coming on top. So most growth of volcanoes come from inside. It's just that rock can be brittle, will crack, and those cracks allow pressure of the dissolved gases to force the magma up to the surface and create lava for periods of time.
I would love to
so
see
when we
Landon.
See these earthquakes, right?
I would love to see Landon try to have a conversation with somebody who's like, volcanoes aren't real.
But anyway, so I think the answer is yes. That and we'll look at when I'm showing. I'll explain again in the map. But most of the growth of a volcano is from the inside. Most of the growth, in mass-wise, comes from earthquakes materially inside it. When it does reach the surface and turn to lava, it's often along spines. More comes at the top than on the side, but that's just but it doesn't. It's not exclusive.
We have from Brian, which I think we should maybe hold on to for a little bit later, but I do want to put the question out there, so just in case we don't end up getting to it, it's already out there. Apparently Greenland is being pretty active, as well as Iceland. That might be something we want to take a quick boo at once we're done looking at the current situation with Pele. But I'll leave that for Landon to decide, depending on how quickly he wants to plow through this. As well as Joker MVP has asked 2 questions. One is, what has been the deadliest volcano ever? And the second one is, and when is the next super volcano around due? How long until we see the next?
I'm not sure about the deadliest one ever. That's something I don't. That is something I don't know.
One at Pompeii, I guess.
Well, I mean, there's been some
actually,
spectacular
the most
ones.
Deadliest.
Was it in Central America or Caribbean?
Yeah.
Well, Smitty is proposing the deadliest would probably be the Siberian traps that caused a mass extinction before the end of the Permian mass extinction, I guess, before the Mesozoic.
Okay, you're talking about critters versus people.
Critters versus people. True. Yeah, what counts as deadly? Like, if you're looking at like what's caused the most damage to humans, I mean, there was Krakatoa, with the big one in the ocean that made people go deaf like miles away.
So according to Wikipedia, it says Mount Mount Tambora in Indonesia, which caused
Yes.
the death toll of around 71,000 to 250,000 people. And the next is
Some
the
of those died from the tsunamis, though.
Krakatoa. Huh? Sorry?
Oh, some of the deaths would have been
Some of those
from
died from
tsunamis, not the volcano directly.
Caused by the volcano. Interesting.
Maanya's
yeah.
out
But then it
here
would still be
with like
it would still be caused by a
propaganda.
volcano. Hey, okay. Oh, okay. I see you. You do propaganda. Madam Pele. I summoned Madam Pele to this live stream.
It's volcanoes don't kill people. It's lava that kills people.
Yeah.
So was that like Joker MVP's question was wrong? Then is that what you're saying? It should be reworded differently.
Oh, I think I think people are just asking for specifics. Like, does Joker deadliest in like extinction? So then, yes, most likely Smitty is correct, I believe.
I mean, in terms of about people that have died, there's been some eruptions that have caused wiped out stuff. And again, I'm trying to remember. There was I think it was may have been in Central America where there was a lava flow or was an island that essentially wiped out a city. They've had some really awful experiences from there. But then there have been the other side of the coin is do volcanoes then get credit for the life that they caused to create? I can imagine in the North Island, New Zealand, some of those volcanoes probably destroyed lots of life. But now look at the Northern Island, New Zealand. It's very rich farmland and very fertile.
So
and do they get credit for the life they help spawn?
So no, the devil gets blamed for all the bad things, and God gets praised for all the good things. That's how it works.
Yeah, including genocide. Yeah, okay, cool. So the Oregano State University website says so they're talking about volcanoes and the death tolls that the explosion or the eruption of volcano caused. Then they're talking about the major cause of death, along with that what came along with that eruption that actually resulted in the death toll. So the Tambora one was starvation. That's what was the major cause of death when Tambora erupted. Krakatoa in Indonesia, it was a tsunami. And then Mount Pele, Pili in Martinique, ash flows. Then the next one, mud flows. Volcano collapse. So it's like it's the event that's caused in chain reaction that comes, like the domino effect that comes after the volcanic eruption.
Yeah.
So I guess the volcanoes
are
kind of
the resulting starvation kills people.
So it's kind of like the picture is like this is the world of the volcanoes, and we are just the guests who are living in here on limited time period. So yeah, it's up to the volcanoes when they decide to kick us out.
Around Krakatoa, the soil is very rich and it's a very fertile area. The recent submarine volcanic eruption that occurred in Polynesia, the marine life around that thing has exploded, right? It when the acid and shock waves killed lots of fish in the area and turned into a kill zone, then life rushed in. And so right now in that area, marine life is actually quite active, quite vibrant.
Lava sharks.
Yeah.
It's
yes.
If
you're blaming the volcano for the deaths, be sure to credit the volcano afterwards for the life that comes out as a result of it.
So, Smitty makes a good point. Volcanoes don't kill people. People with volcanoes kill people. Landon, Maanyaa do wielding volcanoes. But I think we've mostly answered the question, although we get a little bit silly. On the other hand, we have this super volcano thing. Don't get Landon started on King Yellowstone, all right?
Yeah.
Oh no!
But, I mean, there are all volcanic systems that do have some real potentials to create problems. And in Italy, for example, right now there is a concern about a volcanic system where government Italy is considering evacuations.
That will be a good idea.
Because
I think so.
So if I can put up this theory. In fact, there's a picture. Let me do this.
Are you talking about the Campi Fleggery that
yes.
Joker MVP brought up? Oh, okay.
Yes, and so it's the caldera has was a much bigger. It's actually a much bigger volcano than Vesuvius is famous for destroying the Pompeii city in 79.
Oh, yeah, I just brought it up. Yeah.
But it's had a number of earthquakes, but we don't see we don't see gas levels there, but we do see the ground currently rising by. In fact, the number I was given was about 1.5 centimeters a month. The expansion.
Oh.
So there is magma pushing up. Not.
And there might be gas also. There might be gas also in there that might be pushing up, ready to come out. So evacuation would be a good idea. Evacuation would be a good idea.
If Yellowstone erupts next Tuesday, I am going to laugh. I'm gonna have a great time.
Yeah. So it had.
Did you say 1 centimeter?
Some eruptions in the early 1500s, and it had a series of eruptions. I know around almost 40,000 years ago in that region. So it is volcanically active, and there's a whole bunch of people in the area. Why? Because it's got very rich soil, and people tend to like where food grows well.
The whole concept of volcano kind of sounds similar to what we have in Hinduism, with the Lord Shiva. So whenever he dances, it causes absolute destruction of the whole universe, like just collapses. And then out of that destruction comes the new universe, next cycle starts. So it's kind of that thing with the volcanoes, isn't it? They destroy everything around them when they erupt, when they do. But then after that...
Please do this.
And that's analogous to the coil. The Hawaiians talk about Pele's dance, right? There's also how that tradition is.
Electric slide.
Actually, if I may point out existence. If I may, Lord Shiva is kind of considered like he's like combination of both man and a woman. So what if Madam Pele is the female version of Lord Shiva active on this earth? Interesting.
Yeah, but don't tell some people that. Are you saying that Shiva is gender fluid and do gods have trans rights?
I said nothing. Hell yeah.
Do gods have trans rights is such an interesting question.
I mean, given
this.
Some of the religious people tend to hate for some reasons trans people, even though many of them I know, the ones that trans people I know are lovely folks. They would be even worse, maybe madder if they're actually presented with gods or deities.
Oh, I mean, look at any description of angels. They're usually relatively sexually ambiguous, if sexually identified at all. And then also, I don't know, whatever.
Oh.
You're busy being obsessed with Barbie genitalia right now. Don't worry about it.
I guess what we find is that people who are religious fanatics who don't like trans people or gender fluid people, they're scared that these people might be angels or at best gods. So they're like,
Nephilim.
We need to bring these people down before people start recognizing them as angels or gods. Oh boy.
Yeah.
So
I was going to say that from a point of view, trans people are people, and it's nice to be nice. So be nice to trans people, just like be nice to non-trans people, right?
Yay.
What's so hard about that?
That's part of the problem. What is so hard? that's the problem. All right, we can talk about that another time. But the chat is going off about two specific things. I think Landon, you're gonna have to commit to a we have to talk about Yellowstone episode.
Okay, so
No, not right now.
Yellowstone
Not right now.
is
Not right now. Not right now.
okay.
No.
We should at some point, not now, but talk
Yes.
about
Yeah.
major volcanic systems,
Yep.
and that the so-called supervolcano in Italy shows much more signs of unrest, to the point where the Italian government, quite rightfully so, is drawing up evacuation plans. Not to say to people get away now, but they say
Yes.
if unrest gets to be more extreme, how to protect people, and they're doing a much better job.
That it would be a good idea if we're going to do this, that we potentially do it as not our regular tracking volcano episode, but do it as like in addition to.
And get people like Maddie to come forward as well to add additional.
Oh, that's what we'll get Maddie for. Yeah, we'll get Maddie in here to talk about Yellowstone. There we go. I like that. The second one.
Not just Yellowstone, but major volcanic systems.
Yes.
Yeah.
Past and present.
Yeah.
And then there was one other one. Where did it go? Oh, yes, feline.
Yellowstone is not going to erupt anytime soon, and unlikely in your lifetime, and it's not a danger, except to ratings weeks when History Channel wants to.
Oh.
The shade at the History Channel makes me happy. So
if you want to talk about Yellowstone, go on to Twitter or X or whatever that Mr. Poor Impulse Control calls it, and spew it there.
The other one we are looking at is a potential volcano history. So basically, looking at and kind of utilizing modern methods to analyze prior volcanic eruptions. People are very interested in Pompeii.
Yes, and other historical things. But there's can I, by the way, show an answer to a previous question? I'm going to show an image.
The History Channel treats Yellowstone like the Discovery Channel treats sharks.
Oh no!
By the way, so here's a map of lava flow from 1790 to 2018. And they picked 1790 because 1790 was the year that that formed the caldera. Prior to 1790, it was a fairly rounded top, and that thing collapsed. And probably Kilauea's most deadly eruption, and that ended up. We'll talk about them in super volcanoes and deadly volcano stuff, about how it changed the Hawaiian political landscape. So 1790 to 2018. 2018 is when the 35 year eruption stopped. So we look at this map, we can see this is a shape from the Big Island over here. You see this spot here. Here's the part of the Big Island of Hawaii that is Kilauea. So it's a side volcano at the moment, and you can see the two spines, the east and the southwest zones. So shield volcanoes typically have 2 or 3 spines, weak fractures. And as you can see in this history, most eruptions start on the spine and spill out one direction, one side or the other. And until 2018, again, there were eruptions that occurred, but relatively few show up in the caldera. I mean, there have been. 1919 was the last time that the lava lake covered the caldera extensively, and that was a period. It was a wonderful period of time where the whole caldera was almost a sea of lava. 1882, 1885, Samuel Clemens, otherwise known as Mark Twain, stayed at the Volcano House and wrote extensively about the eruptions during that period of time. We can see that most of the recent eruptions have occurred along the east spine. The 2018 event. This orange over here was the area where the lava, about a cubic kilometer, came out in a period of only a couple months, wiped out those homes. And there was a nice bay that was reserved for the Hawaiian royalty, and it was a nice place where turtles would swim in and so forth. That bay was all but wiped out and covered. Most of it occurred from Pu'o'o, was a side vent here that spilled into the ocean, actually on both sides. But we had, in the 70s, we had a bunch of flows also from this area. It has been a while since we've had an eruption down the southwest zone. And remember, this spot right here where the cursor is right now, this was where the previous eruption was coming out on the side, pouring into Halemaumau. You see the Halemaumau right now in this image is a very small dot. Now Halemaumau is a much larger thing, have taken almost a third of the caldera. 1959, Kilauea was the place where you had the great fountain that was 700 meters, around 2,000 plus feet, that occurred at that time when it was spectacular, sort of single event eruption. But you can see along there, it's had some flows in 74. When you drive down the Chain of Craters Road, you go through this area, spectacular rock flows. But we were seeing earthquakes traveling down this spine, suggesting that the magma was finding weak spots and begin to crack. We thought that the thinking was that when the lava lake that was sitting here on top drained down underneath Pu'o, it came out on the edge. It came up so fast that the summit collapsed. That's where that pit occurred. That if it restarted, this stuff has sort of been sealed off and it might go down this direction. In fact, the earthquakes suggested that. But interesting enough, you see some of the stuff here from 1982, this eruption here in 1974, these spots in the caldera. Let me zoom in to give you a better.
I was about to ask.
let's kind of zoom into the spot, right?
Oh, better.
So Halemaumau now is a pit about this big here, right? Not this small zone. And in fact, this little dot here with my current cursor, that used to be the lava lake. Inside Halemaumau was this nice circular pit, and it was a hole in the side of the pit. That was for many years. Whoops. Let's come back here. Come on. Back. Sorry. Trademark Canada. You got to be careful because Canadians
are very... I'd like to remind you that this show is live.
So this little dot here was during that 35-year eruption. That was the extent of the lava at the summit. The rest of it comes out all of this area. Here's the Pu'uo flows. Here is the flows that went down the spine, and here's that end eruption, right? That it went all the way down here and came out. This cubic kilometer of lava were about almost 3.5 to 4 cubic kilometers of lava here. This one occurred within a span of about 6 weeks, causing the summit to fall in on itself at the end of the eruption. So the area that is let's zoom in. Can we zoom in just a little bit more? Okay, I got to go and zoom in a little more. Where is it? Come on. I'm zoomed in too far. Here it is. Sorry about this. The area is just not cooperating with, where is the, oh, here it is. Okay, we're now finding, we'll find it. Here it is. Here we go. So there is the caldera, right? So this circle here was the hole in the side of Halemaumau, which was used to be about 500-meter wide pit, and it only came here. The Halemaumau lava lake and rock is in this zone. This
relative
area
size
here
is so crazy. Relative size is just
Yeah.
insane sometimes.
Yeah. So this is so the previous eruption had a side vent here that was heading down this way for the southwest zone, and Pele's current eruption went this direction. In fact, these cracks here were sort of part of the area that the weak spot, those chain of fountains we saw, was along this zone, right? So from a hazard point of view, you can see where most of the flows came in along the spines, and that's sort of the way that volcanoes tend to work. Now, those are spots where we have historical records. We can go out and measure stuff. There are maps that go much farther back where they can do dating methods. But those were the maps of the recent.
But Landon, the dating methods are fallible. They have been proven not to give accurate timelines.
You can't trust
According to some people,
That's
but
Nah, I'm just joking. I'm joking.
No, I understand. I understand.
I'm joking. I'm joking.
So when we talk about deadly eruptions and big volcanoes, we'll and hopefully we get Maddie on as well. I'll talk about the change of the political landscape as a result of the 1790 eruption of Kilauea.
Yes. Yeah. We also have
any other thing from the chat room?
Yeah, from Shane.
Yep.
Shane T asked, were the other islands in the chain ever as big as Hawaii and then eroded to their present size, or is Hawaii unusually large compared to the other members of the chain?
So the answer is yes, they were. When the hotspot was in that part of the, because the hotspot moves a little bit, but most of the oceanic plate is moving more. So the island group around Maui was once the big island, right? And much further back, Oahu's friends were part of that big island. So the big island tends to be the part that's closest to the hotspot. But as soon as the hotspot moves on, the erosion, the enormous amounts of rain that comes there erodes it very quickly. Now, again, most of the big island of Mauna Loa, which is most of the big island, happened in the last million years or so. Kilauea only broke ground a couple 100,000 years ago above water. So from a geologic point of view, these volcanoes are very recent. But once the hotspot moves on, the enormous amounts of rain reduces the island down to the set. So the big island will eventually, as the hotspot moves on, Mauna Kea and Mauna Loa, the ocean and erosion will cut those into two islands, separate islands, erode away, and then they'll become small nubs, and then they'll become coral reefs, and they'll become underwater stuff as the hot zone continues to move.
I have a question. The fires, the August fires that we talked about, I left the links down below. Do we have any updates about either how things are going there, or are we still definitely sending?
Yeah, people there are really in need because it's no longer in the news cycle, but you have people that are continuing to suffer. I mean, they still need to eat just as much as they did the day or two after the fires. There is a lot of concern about rebuilding because there's a temptation. Some people say, "Hey, I'm out of here, sell it off, and turn it into a big housing development." Other people want to see the old character of the town restored, and there's a whole debate going on as to how to move forward. The charities are still active, and there are still people who collect materials and bring them in to give to people in need.
So I have a question.
Good.
So it might be a controversial one. Maybe we won't discuss it. But so this whole thing about opera and the Dwayne Johnson thing, where they asked for donations and shit. did those donations ever reach the people, or what the fuck is going on with both of them? Why the fuck they are getting involved in this out of nowhere?
I don't know the specific details of that, and when we pick some charities, we pick charities that have had a a long history of helping people, and so that's where we selected some of those that are known to
Can we have some links that we can
good
put in
works.
the live chat, maybe?
The links are down below
Yeah.
in the description right
In
now.
the description? Yeah, guys, links in the
Oh, but you
description.
can put it in the
So,
live
yeah.
chat as well.
Yeah.
It is a case as well, and you still see cases where as they report in like that all Maui is encouraging visitors, right? Because a lot of their economy is on tourism, and
Yeah.
there are places where excess food that normally go to waste is put into trucks and brought into Lahaina to give to people. And you still see, and I think again, this is so much about the island spirit. That the truck shows up, hands out food to people, and immediately they start calling their neighbors, people around there, to come and share, because they may have nothing, but they still have the aloha spirit, and will in turn help others. It's a beautiful part of that community. So I would not go into an area because it still is a recovery zone, and people are still very much in mourning. But the rest of Maui is open for business. And in fact, if you want to do a favor beyond giving in a charity, it's go and visit respectfully, stay away from the devastation area. Don't be a jerk, but be a nice person and contribute to the economy, because that will help. There are a lot of people whose job in tourism or restaurants or service areas are now working elsewhere in the islands, and you can help them by also your tourism dollars, but do it respectfully.
There are 3 options that are down below, so feel free to check out which one is going to work best for you if you're looking to donate or if you're looking to help out. If you're not able to donate and you think you might be able to maybe donate time or something like that, then feel free to use the contact us at any of those websites to see if there's anybody you might be able to reach out to in whatever way that works for you. And remember to take care of yourself, because you can't help anybody else if you can't help yourself. So those links are both in the chat. There are 3 options. There's a Hawaii community one, there's Act Blue, and there is a GoFundMe as well. And they are also in the description down below.
So it is a thing that still is ongoing, and the one of the things I can tell you is that I want to show you this picture that was greeted with much joy. That a friend of mine took. You know that there was a large banyan tree that was a gift from India back in the late 1800s. A massive tree. It suffered a lot of damage, but this is a picture taken by my friends who lives in the area, and we see leaves sprouting.
Oh wow, this is so great.
This is the first, and this had there's a whole big celebration of the fact that the tree is still alive. It's been badly damaged, and the fire damage ravaged stuff there, but the tree is still alive, and this is the first sprout from that great tree. And it was a cause of celebration. They've had little to celebrate about, but this was one of the things where, again, the island is coming back, and
so it's like the island saying, like, don't give up on me yet, buddy. Don't give up on me yet.
And now there are arborists that are looking at what parts can be saved. This is obviously an area where part of the tree, this huge tree that was of talking about mini sprouts, and it was almost like a huge block of tree that Other parts are more damaged than others, but it still is
Right.
alive, and there is stuff coming from there. And so this is a symbol of hope, and was greeted with much joy. So
Good. That is so good to hear. I'm glad for that up. That's wonderful.
And
Something positive,
and
yeah.
that's where I said there's a lot of hope around in the area. Still a lot of suffering. So if you can contribute, again, even if you get a small amount, because people are in need, and the other way would be to donate
Share.
services. If you're a person who has skills in housing rebuilding, I know the Habitat Humanity is looking at trying to do some stuff, but right now there's also a question about how do you rebuild and what to rebuild. That is a debate going on that the people there need to make decisions. So let's talk about what the current volcano is doing, shall we?
Yes. Yes, let us.
Yep.
Okay. So right now, this is as of this morning. We've had a large block of earthquakes starting October 4th. So it's been in the last 2 days. We had 320 earthquakes in the last 24 hours.
Shimmy.
So again, we have fairly good seismicity going on, but the gas is 50 tons per day, so relatively little gas. Lots of quakes, but still, it is, and some of the quakes are around this 1974 eruption event. So it's an area of the spine in the along the southwest zone that is having lots of earthquakes again.
Show me them tilt meters. Show me them tilt meters.
Let's look at the tilt meter. Well,
Yeah.
so let's look at the month-long thing.
I love me a good graph.
This is Shesh's inner goblin coming out.
So let's look at this one here. Here's the
graph.
month-long thing. And this was we were saying it's not doing much. There's a little bit of tilt meter. We couldn't quite tell, and then bang! Right. This is the oomph, 30 plus microradians. This is
That's
the
that
eruption,
sneeze
right?
that I talked about.
And this is the climb down from it, right? And so it
Now
lasted from the 10th, right?
Yeah, it's so funny, like looking at that graph. All right, so the current stage is still higher. It's gone still higher than the original, where it went bam from. So like it's decided to still climb up, and now it's more than the level that it was before when it went bam.
Yeah.
So yeah, like you see, the reference point is 0, right? So compared to that, now what we see on the 4th of October, it's around 10, and you're like, what do you want from us, Madam Pele? Really?
So here's the start of the eruption on the 10th, 11th, and the end of the eruption is around the 17th. So this is what the eruption occurs. So in some ways, the tilt meter is not a good indicator that the eruption is imminent. It's more of a indicator of the health of the eruption, right? Or the health of the magma chamber, the energy flow into it. It tends to be less of this blip means there's going to be an eruption, right? Because if you looked at when we had the last month, the show that ended up. What was our last show? Was on what date?
I have a calendar around here somewhere.
That's the last show. Previous show.
Yeah.
1 second.
9th of September.
Yeah. Okay. So we had a show here, right? And remember, we were looking at stuff. We were saying, well, is that a DI event? It's sort of anemic, but might be there, right? That's not a good indicator of that. Tilt meter is not a good indicator that eruption is imminent. Tilt meters are more effective when eruption's ongoing as to the health of it.
Okay.
And the fact that it had to climb down, there was a little bit of a DI event here, but not much, and the eruption petered out. Had that eruption ongoing, the tilt meter would have seen the turnover in the magma chamber much more healthy. So anyway, that's from the last show to this show of last month, and the eruption. Let's look at the past week, and we see it's going along, and we might have said, yeah, there's a little bit of DI events, and then all of a sudden it decides to go whoosh up. And if we look at the last day, because I was going to say, yeah, it's kind of going, except on the 3rd it started taking off, and it kind of leveled off there. And then this is a classic deflation inflation event. This is this downward decelerating. It pivots and upward accelerating, downward, upward. So we see that we've had 2 DI events occur in fairly short order, suggesting that there's energy coming in the magma chamber. But here, the magma chamber is kind of exposed to the surface, so it's not going to behave like a classic magma chamber in that sense. So if you had been at the show back here, we would have said, yeah, it'll kind of go on and on. And then we saw this takeoff that sort of says, oh, here's a inflation event, but it did a short DI back. This is a fairly healthy deflation inflation event, suggesting that there's energy coming in underneath the thing. So having earthquakes doesn't mean the volcano's active, right? A contracting volcano that's going from active to dormant and extinct, you'll get cases where essentially the rocks contract and crack and create quakes. So quakes are not necessarily indicative of eruptive or magmatic movement. And some magmatic movement, when the magma is receding and the expansion contracts and cracks, you get quakes like that. So quakes alone don't tell you what's happening. Tilt meters can add to quakes, and so this suggests that the magma chamber system has energy coming into it. So the 320 quakes we've had in the last 24 hours, the previous 24 hours, about 160 quakes, combined with this tilt meter stuff, suggests that magma is on the move.
Magma is on the move.
Moving.
Let's look at the other thing. Let's look at this here. Look at this GPS. Now this is the expansion across the caldera, and we saw this blip. This is the eruption that occurred, dying down, and we see it's almost up to the pre-eruption height. Yep. But it's been going, right? The previous eruption here, this was that previous eruption, and the eruption before. We look at a larger set. Here's an eruption, here's an eruption, here's an eruption, here's an eruption, and here's another eruption, and it's almost up to the same levels as before. So we have the mountains continue to expand. We have lots of quakes underneath. We have, the gas levels aren't there. That means the gas is not reaching the surface. We also have the beginning of what looks like deflation, inflation events.
Yeah.
So unlike last show, where it was kind of anemic, we're now seeing signs of potential activity.
We did get a comment from Gup on another video that I wanted to bring up real quick. So this is a comment that Gup left on the video where we briefly went over during the tavern. It says, less than 3 weeks ago, its almost recent summit eruption, Kilauea is showing signs of unrest through an earthquake swarm and elevated ground tilt near the South Caldera once again. This suggests magma recharge has been ongoing and has quickly resumed building pressure in the summit reservoir. It appears the buildup to the next eruption has begun, once again contained to the volcano's summit with no unusual activity along the rift zone or near populated areas. Given how quick the resumption of the escalation of earthquakes, the USGS Hawaiian Volcano Observatory today resumed its daily Kilauea updates. This same area of activity saw numerous swarms of what's the word I'm looking for here? Wigglies. Hello, brain? Why am I done? Earthquakes. Sorry. Earthquake swarms.
Yeah.
Numerous earthquake swarms started about 3 weeks before the September 10th to 16th, 2023 eruption, along with its localized inflation most evident east of the Sand Hill Tilt Station about 2 weeks prior. The similar ground tilt signaled this past week, totaling a significant 30 microdarians, began to level
Microradians.
Microradians. Okay. Microradians began to level off, coincident with the earthquake swarm. However, the slightly different pattern than before. Back in August 2021, an intrusion in this area recorded a similar leveling off in each of its 2 stages. It remains to be seen whether the current pattern of intrusion will continue and whether it resumes its progress towards eruption. Whew! I did it. I read the big comment. Did we lose Landon? Landon, did you mute yourself?
Uh-oh.
I was getting feedback. I'm trying to avoid the feedback thing, so give me just a moment where I resume the set because the iPad decided to take over my headset. So I was stopping it because you would have gotten lots of feedback.
Oh no! This dirty Apple user.
Okay, we're back.
Yes. Hello.
Okay, I apologize. The iPad grabbed my headset and I was getting audio that then started coming out on the speakers and didn't want to give you. Sorry. So yes, thank you for reading that thing.
I did the thing.
All right, so we're back there. So here's the map. This was a map taken on the 14th. And we saw remember it's sort of the middle of those volcano images with those pits that had little cones around it. So you see the yellow dots, and you can see the lava that was flowing. So the pink was the full extent of the lava that came out of this eruptive vent. The previous eruption was here on the side around near where this H of Maanyaa was flowing into the caldera. So that's where that purple area was a higher. That was the June 2023 lava event, and the other lava coming from here couldn't quite get there. You see you see how far up some of the cones went, almost to the floor of the caldera. Right, caldera is around 3,500 feet, whereas most eruptive vents are around 3,000 feet. So there's about 150 meter difference between these vents and the caldera floor, and people are quite excited because it almost got up to the top pouring in, but again, this large rift occurred. Look at where the camera was placed. Right there.
Oh wow!
That camera is blessed by Pele. That needs to be auctioned off, and the funds be donated to the Hawaii, the Hawaii fires. Yeah. That camera needs an auctioning off.
To be said, we saw that ridge line. It was placed up higher on the ridge for a purpose. That being said, it's pretty lucky that it was there.
Wow.
So we can see that the previous quakes and the rift stuff down here coming from the side vent was not where eruption occurred, but the eruption occurred on here. There's a whole fault area that ended up reaching over Kilauea, as Red Eye pointed out. There's a fault zone that in 1959, this is where it had a famous eruption. This used to be a nice pit full of all kinds of trees and rare plants that got burnt up when it erupted over here. And there's fault zones here. The actual shield volcano, if you look at the shield line, the fault lines run down this direction. But there's another weak fissures here. In 1974, and other than 1971, there were eruptions inside the caldera in this zone, so it's known to be a weak area, and obviously that's where the magma came out. Again, the pink is the extent of the flow. The red was towards the end of the area where these are the last vents, and now it's quiet. So that's the map showing what and again, it was the full lava extent was around 201 hectares or 496 acres. That's what the pink is. So it was a fairly large coverage of the area. And again, it gets harder and harder for it to create elevation, because now it has to go for larger and larger areas just to get a just to cover it. The question is, do we think it will fill up this entire zone before erupting? Well, if you saw that previous map, most of the eruptions occur along one of the rift zones. Historically speaking, the last 200 plus years has been along this spine or that spine, and not at the summit. So it's possible that if as this open-faced magma chamber always has been covered with almost 150 meters of rock, the open-faced magma chamber, as it gets larger, it's going to be harder and harder for the eruption to come to the middle, right? We've seen the last two eruptions side and side, not in the middle. As this cap gets bigger and bigger and bigger, it's going to force the magma to one side or the other. And which side it picks is chaotic. Obviously, it surprises us and pick the other direction. But I would say it's safe to say that if there's going to be a summit eruption, it's going to be either this area again or this area. Now, this area here has had recent cracks, but those cracks are now being plugged by congealing lava that's going to make it harder for the gas to get up there. As the mountain expands, cracks may send it this direction instead. So, but I think if you're going to see eruption, it's going to be either this area or this area. If we look at the thermal images again, you can see the extent here is September 11th when the eruption was ongoing. You can see it got up quite high on this rift zone here. If you had been here in like, like for example, in the 1990s, and you were able to walk across this floor, you would have come across some small cones here from the 74 eruption. Obviously a weak spot that it reopened. And you can see how the flows, were coming up all over the place, diminishing, and diminishing. Right? This is a typical kind of thing. So will it come up when it erupts? Will it come up here again, or will it come back over here? That's a pretty chaotic thing about one or the other. Hard to say. From an earthquake point of view, we see again lots of earthquakes, relatively shallow earthquakes, heading
so
many. And off to the southwest. If you look at this spot in the last 7 days, we look at the last day, we've had 284 earthquakes in this zone in the last day. And we see relatively shallow stuff. I mean, this is 2 kilometers, 1.3 kilometers deep, 1.2 kilometers deep, very shallow, 4 kilometers. So they're within a couple of kilometers of the surface. This is that southwest zone spine. Even though most of the
that I'm interested in.
Yeah.
The southwest spine. Ah, yes, as we all know, just above the left butt cheek. Southwest spine. Yeah. Northwest would be the shoulder blade.
Yeah. I'm glad I'm not drinking anything at the moment.
These are small quakes, I think the biggest is in because we look at the 2.5, there's only 4 that are above 2.5. Yeah. Most of them are small quakes, but again, this is just magnetic activity. This is the old contour, the Maanyaa pit is here.
Oh yeah.
And so it's heading down this direction. Now remember, I was doing this before, and it came out this side. So just because the quakes are going this way doesn't mean that's where the magma is going to go.
Right.
So we're almost back to the same thing as last month, but we now have more definitive deflation events. We have even more quakes. We don't have the gas. So you told me, webcam wise, we can see here is the current thing. These are these lovely little pits There's looking off towards the Holy Mau Mau lava pit. Here's another one showing down drop block and its motion this way. Air quality is pretty good because there's not much gas. And here's a live picture. And we can see in this area, there's smoldering from the previous set here. This is looking off to the southwest zone. So this was the area where the previous eruption that came in this direction. Right? This is where it flowed in. This is looking off towards the southwest rift zone. This is where all the quakes are heading off in that direction. We'll wait for the camera to move. But so again, and here's a side event. See that thing? This is that side event.
You can see where that wormy went its way along, and then Deja Vu drifted its way around the side there.
Because kind of reached here, it's harder to get.
I'm pointing with my finger, like you guys can see anything I'm doing.
Yeah, this is the wormy bit down here, like this way, right? Yeah. I kind of stopped because this is elevated stuff where it poured in this direction. And again, most of the quakes are in this direction going off down towards the coast. That's where the quakes are. That was last time as well, but it ended up getting to the other spot. We'll wait for it to shift over to the side. There we go. And so here are those vents where it was coming in, right? This is the vents that were pouring in here. Obviously, there's still some outgassing in this region of the center of the lake. Still quite fresh lava here from the previous eruption. So, question becomes, well, what is going to happen, right?
What comes next?
What is it?
Prediction time.
Prediction time.
We need to make a transition for that. That's Shesh, like you do on the unnamed cabin.
Oh, okay. Landon, you gotta come back.
This is where we get to show how chaotic the volcano is. It is fairly safe to say that Kilauea will erupt again. Right? I almost guarantee that. It's still an active volcano, and it will probably be erupting, for the next many hundred thousands of years. It's fairly safe to say that the frequency eruptions will be about 50% of the time. We know that there's deflation-inflation events suggesting there's energy coming up. We have a bunch of earthquakes to the southwest rift zone, increasing in number. Gas is not present at the top yet. So unlike last month, we have more definitive deflation-inflation events.
Yes.
Unlike last month, we actually have a higher number of quakes.
Yep.
So,
nothing's
should we ask
gonna
the
happen.
chat first?
Nothing's gonna happen. We ain't seeing shit for another month. That's my prediction. We're not gonna see shit.
Okay.
Yeah, we're not seeing nothing. We're getting edging right now. That's what's happening. We're Pele volcano edging. That's what's happening. This is foreplay.
So let's ask the chat first. What do you think? What does the chat think? Weigh on
what are your predictions? Let us know. This is gonna take them a minute to catch up though, so give them a sec.
So again, and help you
Landon.
understand. Between last event and this week, we had an eruption. Last time, we did not have as definitive deflation-inflation events as we do now. Last time, we had quakes, but not to the frequency that they're happening now. The mountains continue to expand. 50% of the time, historically, Kilauea is erupting. So, you tell me.
So Shesh is saying that we're not gonna see shit for the next month. This is foreplay. I would
in the
say
chat says October 17th.
Okay.
eruption on October 17th.
I say we will see an eruption, but it's going to be smaller than what we saw in September. There will be something, but smaller, on a smaller scale, not as spectacular as, yeah.
And Maanyaa, I think there's wisdom in what you're saying, because the amount of material that is going to come out. I mean, it's already released a lot of pressure, and so we had a couple of months buildup before this eruption, as I recall. So we don't have as much. So the question is the influx of energy higher? If it's about the same, then I think you're right that if it does erupt, it will be of a shorter duration. So I think next time we meet, we will see an eruption, but it might be, as Maanyaa said, shorter. We'll definitely see deflation of ancient events pre-sound. We will see continued earthquakes along the south rift zone. As to where the eruption will occur, it's anyone's guess. You might say, well, it's already erupted to the east of the lava lake, so perhaps this will be something closer to the southwest area again, where the lava might come out. But I don't think we'll have a major eruption.
Yeah.
And,
I think we're getting teased. I think we're getting an eruption teased for us, and it's not going to happen for a little while still.
And if you talk about saying you want big eruption, you want a big event, you'll get a more likely big event with a longer pause. So if you're hoping for a bigger event, you'd want a longer pause, usually, except if in fact it's under great stress. The thing we're not seeing is a contraction of the mountain. We're seeing the mountain expand. So magma is definitely pushing up against this thing. It's meeting resistance in the big lava lake. And so if you had to pick which side of the lava lake the eruption will occur, I'm going to guess southwest rather than east, because it's already gone to the east and that's kind of congealing. And that's where the quakes are. But we're wrong.
Yep.
So yeah, if it does erupt, it'll be a smaller eruption, like Maanyaa said.
We also have Katina in the chat is guessing an eruption for October
22nd. We're getting competition around the predictions of the dates. Oh my god, we got psychics here.
We got 3 straight up eruption predictions, and then we have Landon being a little bit more reserved than that. And then, so 2 straight up predictions to the day. Maanyaa pulling that back a little bit to say that it's not going to be like a full eruption, but more of like a smaller event. Landon pulling that back even a little bit further, and me just being like, nothing's happening. We're going to see like the same trend continue. I'm telling you, man.
Well, that set of eruptions, that set of predictions kind of covers the possibilities.
Yeah.
Actually.
Somebody has to be right. If we guess everything, someone's going to be right eventually.
Well, no one has said that it will be a proper eruption like the last time. No one said that. Imagine if that happened again.
No, they're saying proper eruptions on the October 17th.
Gup and Pack. Okay, yeah. All right, so theirs is the okay, gotcha.
Yeah.
Yeah, and I think it's a matter that you look at the history of the eruptions, of the history of the killer eruptions is. I mean, we have a list of eruptions. Let me just come back here and show you the historical list
My mom says she thinks Yellowstone is going to erupt next weekend.
She's like, I don't know. I don't even want to mess with Madam Pele. Nah, I'm gonna talk about something else.
My mom's trolling.
Hi, Mom. So here are a list of dated eruptions, right? For things, and some of them are long periods. So this was the Great Caldera eruption. So we'll talk about this thing here, VI4 event. One of the things of one of the more significant eruptions in history. But we can see we've had quakes there. Small. Here's a couple of days where here is a number of years. Here's a year. Here was almost a year. But you get a couple of days. Going forward, here's something days where you just have just one day eruption.
Oh yeah. Oh wow.
60s, right? 64, 65. Here is a couple of days, one day, couple of days, a week or two, a week, blah, 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 couple of days, and then 35 half years, right? For stuff. And then we had a brief period, and of course, they don't have the last one yet. They haven't updated this table, but you can see that most of the time it's just a couple of days, one day or a couple of days to a month. That's most of the time, but you do have periods of time where it lasts for weeks, months, or even years. Going back, we have known other quakes even further back, but we have historical records going back to here, and we have really good observation, good dating stuff for previous things. So if you look at this span here, we can see that here's in terms of gaps. Let's look at the gaps from 1790, right? 1790, there was almost a 50-year gap after this great quake. 3-year gap, but then pretty frequent. And then here's a 20-year gap, and then and here's a 10-year gap, versus almost frequent things, but in a couple of days here and there. So if we look historically, we've mostly had these 1-2 day events to a couple of days.
Yeah, and it's kind of like it indicates to the point, right? You would rather had Madam Pele dancing, once a month or once every 2 months, rather than not dancing at all for like 5 years or 10 years, because then you will be like, Madam, what are you up to? What are you up to, please?
I mean, there's almost
time for the whiskey offerings. Yeah.
So it's had periods of time where it's gone on and off. I just wanted to show that it varies from these long period, short period stuff. It tends to be that when it had a really significant eruption, it has a significant pause, but that's not all the time.
Yep.
So
come back, Landon. We gotta say goodbyes.
Thank you. And goodbyes.
Landon,
we have. Oh, sorry. Coming back. Let me come back here.
He's gone forever. Reeling him back in.
There you go.
Yeah!
All right. So I guess coming up.
Yes.
There is
so yeah, go.
Go ahead. No, you go ahead.
Yeah, go.
You first.
All right, I got it.
Okay, I'll go.
So on Saturday, there's a video coming out, and it will be a video of the tavern of the live stream that we had previously. It'll be one of the videos that I was able to get out of one of the topics we were covering. So if you're interested in those topics and not interested in following the entire live stream, please go feel free to check those out. Make sure you like and subscribe and all that stuff, because there's videos coming out throughout the week and throughout the month. I will be live on Tuesday on Twitch if you're interested in that, and if you're interested in goofy nonsense, like it is goofy nonsense at this point. Fridays is Dumb Fact Friday. And Sundays I play games, and Thursdays we do art. So you go come find us in other places. Links are down below. What are you talking about? Yep.
Tuesday, you will find Shesh on Twitch.
Yes.
Again, talking about goofy stuff.
Yes.
More on the serious side kind of thing. Me, you'll find me on Volcano Watch, Dumbfake Friday, Unnamed Heaven, in Shesh's Discord, and on Twitter, rage tweeting and stuff, because and you will usually find me updating a lot around the Andrew Tate, that a-hole. You'll see me updating a lot around that. So if you want
next
updates,
tavern is the 21st.
What a Tesla that person is.
What a Tesla. God. Imagine on spontaneously combusting.
Yep. And it kind of looks like, if I may just interject here. So apparently his app, that was the real world app, has been kicked off the Google Play Store and the Apple Store. So that's his main source of income at the moment, since all his property and all his Bugatti have been taken off from him. So yeah. So and there's a video going around where he's clearly rattled and going off unhinged. So yeah, it's on my Twitter timeline if you have a look at it and enjoy seeing a fucking asshole get the up comments. So it will be great.
Probably
the reason
talk
the apps
about Tate on Friday. Next Friday.
Yeah. I'll leave it here. That's me. Thank you. And Landon.
So I want to say that one of the things I'm going to do is I'm going to go visit I'm going to watch the annular eclipse on October 14th. I'm going to screen share here again, show you a map. This is on October 14th, and we'll watch over several hours the shadow cross. So the colored zones are there, but the red is where you'll have the moon coming in front of the sun. Now that's over a couple hours, right? So we go again here. If you talk about, I'm going to be probably about there. That's where I'll be approximately. So this red zone would be where the moon cover is in front of the sun, but because the moon is elliptical orbit, the moon is far at this stage. It'll be too angularly small to cover the sun to get a ring. Any place outside of here, these color areas, you'll see a partial eclipse. So if you're in this sort of orangey
drive over
spot, you will see a bit of the sun being covered, but don't
forget to not look directly at the sun.
Orange-haired dude. Yeah. Don't look at the sun. Use safety glasses if you can look at it.
Oh, you're gonna get orange eyes.
Oh boy.
Yes. So, but as I say, the dot, comes in. So it comes into North America about here. So this is Oregon going through Utah, Arizona, New Mexico. It crosses into Texas. This is a spot where the total solar eclipse will pass this direction, the opposite way. And it heads into Mexico, South America, and this is where it ends, where the eclipse begins at sunset and slides off to the Earth. So this is the area that center dark zone will be the area where you'll get nice partials. Where we have the lighter zones, we get very partials. So people in this lighter yellow area will see a little bit of the spot. So anyway, that's a thing to see. Let me come back. So I'll have that coming up on October 14th. Again, use safety glasses when viewing it. And then we have the Unnamed Tavern, which I believe is on Sunday?
Saturday. Wait, did we change it for Sunday next week? I don't think we did. I think we did.
I have, but I could be wrong.
I wrote down Sunday. I wrote down Sunday too, and I thought I was just being stupid. Did we move it to Sunday for some reason this Sunday?
Yeah, because there's something that happens on Saturday where it wasn't able to be.
Something was going on, and I can't remember what it was.
So I have it
It's
for
on the
Sunday,
22nd.
October 22nd, starting
Yes.
at 13:30, 1:30 p.m. Pacific.
Correct. So that'll be on the 22nd, and we will be here, and we will be square.
Yes,
Yeah.
and yes. So the Canadian Thanksgiving, and so you Canadians planning on being thankful about something?
I think we're planning on drinking.
Yes, I hope
Thankful
so.
for the booze.
Hope if Pele does things, and of course the moon will be in front of the sun, but
I guess
just not big enough.
I'll be thankful that the banyan tree survived
Yeah,
in Hawaii.
that's
Yes,
huge.
that
I'll
is
be
a
thankful for that.
We take
that is
booze.
an immense amount of joy. So
Hog.
it will. It would be appreciated.
Thank you so much for joining us today. This has been a lot of fun. I just like that I'm able to, after doing this for a year, I'm now able to get excited about tilt meters because I know what they say. Yay!
that are obsessed with tilt meters and volcanoes. So
And
I mean,
yeah.
goblins have always
Please-
been about tilting.
Please,
Yeah.
hope you continue watching the show and coming on the journey. You will begin to get the notion of the rhythm of the mountain and its cycles and its changes of phase, so that you'll get a better sense of what an active volcano does. And we're glad you've been watching this stuff, and we will continue to do this on a monthly basis for Pele's Time of the Month to see what kind of dance she's doing or whether she's quiet. Um, and
Thank you so much
see
for
how
joining us.
wrong our predictions are or right.
Bye.
Bye.